here and meet there. My classes, Google Drive. Let's look at the chemical level of organization. Okay, so we've presented this once. We're going to review it again because there seems to be considerable confusion about the uh, what chemistry you have to know. So read through these slides. If you have a question, you can ask the teacher or ask me right now. Any questions about these first slides? Your job is to read these and understand them. So ionic bonds is when electrons are lost or gained. So if we look at the next slide, you can see that sodium metal has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 electrons. Metals tend to lose electrons to nonmetals. So this chlorine will gain an electron, go from 17 to 18. So the sodium actually has a positive charge now because it lost an electron, and the chloride has an extra electron, so it's negative. The body depends upon these charges to do chemical and electrical work, and that's how we live. That's how we have nerves. That's how we have muscle activity. That's how we think, based upon how these charges are separated in and out of the cell. Okay, a sodium chloride crystal is a regular cube with alternating sodium and chloride. Make sure you know these symbols and these names. Covalent bonds share electrons. So in hydrogen, they share 2 electrons. Oxygen shares 4 electrons. And each of these carbons and this oxygen each shares 4 electrons. If the electrons are shared equally, that's a nonpolar covalent compound. Carbon-carbon bonds, if the electrons are shared unequally, that's a polar covalent bond. And the classic non-polar bond is between oxygen and hydrogen. And water is the attraction between the slightly negative oxygen and the slightly negative hydrogen, slightly positive hydrogen, is a hydrogen bond. The fact that water is a polar compound, it's also called a dipole because it has a slightly negative pole and a slightly positive pole. So these characteristics of water are very important. Okay? We don't need any of this, any of this, any of this. Let me take a break. I'll be right back. My dog is bothering me. Okay. Okay, I'm back. Okay, so you should know the next concept. Enzymes are proteins that lower the activation energy. You know that if you take sucrose, table sugar, you can put that in a pot and heat it and you can burn it so that all that's left is carbon and water is released. So it takes a lot of energy to decompose sucrose. But your body can do it with enzymes because enzymes promote reactions at a very low activation energy. So you should know that enzymes are proteins. You should know what activation energy is. It's the amount of energy to cause reactants to go from uh, individuals that couldn't be joined. And enzymes lower the activation energy. We don't need that. Uh, Make sure you know inorganic molecules versus organic. Large molecules such as sugars, proteins, and fats are composed largely of carbon and hydrogen. Recognize these formulas and names. These properties of water are very important and due primarily to the formation of hydrogen bonds. So this is a slightly negative pole. It's not -2, that's incorrect. But when water dissolves salt, notice that the chloride is negative, so the positive part of the water molecules surround the chloride and dissolve it. The negative parts of the water molecules surround the sodium and cause it to dissolve. That's why water is a universal solvent, because it's charged and it can arrange itself around various molecules to cause them to separate from a crystal. Okay? Most of your body is water, and the proteins and nucleic acids work only in solution. Know what an acid is, what a base is. Acids release hydrogen in solution, hydrogen ion. Bases release hydroxide in solution. This is a base will react, this OH will react with this hydrogen and form water. We talked about this already. So make sure you recognize that 7 is neutral. Extremely acidic is around pH 1, extremely basic. Read through what substances have what pH. The body's pH is around 7.34. Buffers maintain pH. They release hydrogens if the body fluid is too basic. They absorb hydrogen if the body fluid is too acidic. The major buffer in the body is bicarbonate. We'll learn more about that. A salt is a metal ion plus a non-metal ion. They can carry electrical currents. That's very important. Organic compounds, carbohydrates, lipids, proteins, and nucleic acids. Carbohydrates can be monosaccharides, disaccharides, and polysaccharides. So your job is to recognize this as a symbol for glucose. It's a hexagon with 5 carbons. Carbons are here and 1 oxygen. So glucose is the major fuel of your body. You should know what dehydration synthesis is. So if I take glucose plus fructose and the enzyme removes water and forms a new bond, that's dehydration synthesis. If you have sucrose and you add water back into the compound and separate glucose and fructose again from sucrose, that's hydrolysis. So you should know what dehydration synthesis is and what hydrolysis is. This is glycogen. Glycogen is called animal starch. When you eat any type of sugar, it generally ends up in the liver stored as glycogen, because glycogen takes glucose molecules and joins them into long branch chains. If you eat too much sugar, you're going to release insulin. And, don't eat pure sugar. I eat it all the time. I'm very bad eat fruits and vegetables. Make sure you read this table that you know about these characteristics of organic compounds. Lipids, read through this. Okay, this is another example, just like I showed you the amino acid. This is oxygen, this is carbon, this is hydrogen. Fatty acids have a long hydrocarbon tail that is hydrophilic, that does not dissolve in water, and it has a this is hydrophobic. It's like a wax or an oil. This is hydrophilic. It loves water. Oxygen is very electronegative. It has an excess of negative protons. Negative electrons. If all of the bonds of a hydrocarbon are single, that's a saturated fat, more calories. If it's unsaturated, they can be double bonds. Triglycerides are when you take 3 fatty acids and do dehydration synthesis to join 3 fatty acids to glycerol, and that's called a triglyceride. Notice that the hydrocarbon chain, which is hydrophobic, is all carbon and hydrogen, whereas the fatty acid carboxyl group is carbon and oxygen. Make sure you just recognize cholesterol, and it's a 4-ring structure. It's the building block for steroid hormones, estrogen, testosterone, aldosterone, and it's a component of cell membranes. Phospholipids, very important. So a phospholipid has 2 hydrocarbon hydrophobic tails, and it has 1 hydrophilic or polar head. And we talked about how those are put together to form cell membranes. Proteins are made of nitrogen, oxygen, hydrogen, and a bit of sulfur. They're very abundant. We have hundreds of thousands of proteins. Know what proteins do? Okay, let's look at an amino acid. So an amino acid has an amino group, NH2. It has a carboxyl group, COH, and central carbon. And our group is a wild card. This can vary. Okay, if you put 2 amino acids together by removing water, that's also dehydration synthesis. When you remove water and form a new bond, you form a peptide bond between 2 amino acids. If you put many amino acids together in a certain order, you have different shaped proteins which have different functions. Hemoglobin carries oxygen, myoglobin carries oxygen in the muscles, and keratin is a fiber in reinforcing your skin. Okay? An enzyme takes substrates, puts them in a favorable connection, and it makes a product, and it's not used up. Remember, an enzyme is a protein. That's all we need to know about that. So let's minimize that and go back to this and shut down recording to have another